So first of all, what is the, let's see, what time is it? 2:21. So I'll go till 3:35 Pacific time. Okay. Problem 1. Feel free to chat at any point. I'll check it periodically. What is the value of 2112 minus 2021 squared over 169? Okay, so that's 13 squared in the denominator, and that's 91. So it's 91 over 13 squared. That's 7 squared, which is 49. Okay, so that should be C. And I'll check my answers after this is done to make sure that I haven't done anything stupid. I probably will make a silly mistake at some point though, so be prepared. Okay, Mankara has a 4x6 index card. She shortens the length by 1 inch. The card would have area 18 square inches. Oh, so she lengthens, or she shortens the 4 side. So the 4x6 becomes a 3x6. Okay, and then what would the area of the card be if she shortens the length of the other side? Okay, well, it would be 3x5. So wait, what am I doing wrong here? Let's see, wait, what am I missing here? Shortens the length of one side. Oh, wait, does that mean like a... I feel silly for getting met. Oh, the AMC 12 problems are on the AOPS website. Yes, you can tell me if I make a stupid mistake, but I won't look at that until after I've solved the problem, or maybe if I'm really stuck on something. If she shortens the length of one side, the card would have area 18 square inches. Am I really missing something this basic? If she shortens the length of one side, so it's like that? What am I missing? Oh, if she shortened just the, okay. Okay, so it's 24, so that's if she cuts off if she cuts horizontally like that. So it becomes a 3x6, so a 4x5 is 20. Okay, wow. There we go. Yes, I was overcomplicating. Yes, that was a bruh moment. Okay. Okay. Let's pretend that didn't happen. Okay. Next up, we have number 3. I can usually handle 17, but I can't handle number 2. Okay, Mr. Lopez has a choice of 2 routes to get to work. Route A is 6 miles long, and it goes 30 miles an hour, 5 miles long, 40 miles an hour, except for a half-mile stretch. Okay, how many minutes is route B quicker than route A? Okay, route A is 6 miles long, and it's 30 miles an hour, so that's a fifth of an hour, so that's 12 minutes. And B is 5 miles long, and he goes 40 miles an hour for 4.5 miles, so that's 1.5 minutes per mile, so it's 4.5 times 1.5 minutes for that section, and then a half-mile stretch where it goes 20 miles an hour, so that's another 1.5 minutes, so it's 5.5 times 1.5, which is 5.5 plus 7.25, which is 8.25. So it should be 3 3/4 minutes faster. So that's answer B. Yes, I was a TA for intermediate counting and probability. This is, I'm ashamed that I messed up problem 2. Okay, let's see. problem 4. We have a 6-digit number, 20210A, and that's prime for only 1-digit A. Okay, well, I know A is odd. A isn't 5, because then it's a multiple of 5. The sum of the non-zero digits is 5 plus A, so A can't be 1 mod 3. So, okay, 1, 3, 5, 7, 9. It's not 5. It can't be 1 mod 3, so it can't be 1 or 7. And then which, maybe mod 7? So let's see, 200,000. Oof. Well, I know 1,001 is a multiple of 7. So, so if I multiply that by 200, 200,200, it's divisible by 7. Okay. Let's see. So I've got 202,000. Or 200,200, and I want 202,000. Ugh. Okay, well, if A is 7, it's not going to be divisible by 7. If A is 3, then I get 202,103. Then I add 7, I get 202,110. So if that's a multiple of 7, then so is a tenth of that. And then I can subtract 21. Is that a multiple of 7? I don't know. Now I can get 2019 and then add 21,204. Is that a multiple of 7? Well, 98 is 196. 196 plus 8. Okay. Divisibility by 13. Okay, I'm gonna come back to that one. I know it's ridiculous that I'm skipping number 4 for now, but I haven't thought of a really clever way to handle that. Okay, number 5. 44 equal strides to walk between consecutive telephone poles. The ostrich can cover the same distance in 12 leaps. The 41st pole is 1 mile. Okay, so the first pole is here. And then the 41st pole is, so that's 40 gaps equals 5,280 feet. So each gap is 5,280 over 40, which is, lots of chat. Okay, I need a different mod. Okay, I'll come to that. I'll come back to that problem. Okay. Okay, so this is 528 over 4, which is 125 plus 132. Yeah, so 132 feet between poles. So the emu is a 44th of that, which is 3 feet. And then 12 leaps is 11 feet. So that's a difference of 8 feet. Okay. I'm still getting warmed up. It'll take me a little while. Okay. Let's see. Okay, problem 6. We have an annoying geometry figure. Okay, so point E lies on the opposite half plane determined by line CD. Okay, point F lies on AD, so DE is DF. Okay, what is the degree measure of AFE? Oh, okay, so this is 110. So these this angle here is 20. And that's got to be the sum of these two angles, DFE and DEF. So, and this is an isosceles triangle. So this is 10, this is 10, and then AFE is 170. Okay, I hope that's an option. Freest problem on the test. Yeah, that wasn't too bad. Okay, so number 5 is 170. Yes, very pog. I don't know, not my words. How is this? Oh, cute angle chasing. I don't know, it's pretty obtuse. That was horrible, but that wasn't much angle chasing at all. Oh, was that? Oh, that was problem 6. There, I made a mistake. Number 7, 100 students and 5 teachers. In the first period, each student is taking one class, and each teacher is teaching one class. Blah, blah, blah. Let T be the average value obtained if a teacher is picked at random and the number of students in the class is noted. S be the average value obtained if a student is picked at random and the number of students in their class, including that student, is noted. Okay, so we've got 50, 20, 25, 5. And okay, the average value obtained if a teacher is picked at random and the number of students in the class is noted. Okay, I just add these up and divide by 6, or divide by 5. So there are 100 students and they're an average of 20 students per teacher. And then out of all the students, okay, that's a little tricky. Okay, so T is 20 students per teacher on average. And then for the students, there's a 50 out of 100 probability that I pick one of the 50s. And then, am I left-handed? Yes, I am. So if my handwriting is bad as it is, it's going to be even worse with my right hand. So I'm sticking to my left. Okay. Okay. So yeah, then 20 over 100 times 20, blah, blah, blah. Okay, so it's 50 squared plus 20 squared plus 20 squared plus 5 squared plus 5 squared, all over 100. That's 2,500 plus 400, 400, 800, and then plus 2 25s. Okay, so I get 30. Okay, I need to be careful. Don't do anything stupid. 3350 over 100. That seems about right. 33.5. So then T minus S is negative 13.5. Okay. Tell me if I do anything ridiculous. Okay. Number 8. Oh, finally some number theory. Okay, m is the least common multiple of the integers 10 through 30, and n is the least common multiple of that, and the numbers 32 through 40. What's the value of n over m? Okay. Okay, so I basically just have to see how many extra prime factors. Wait, we should tell you. If I do something really silly, I'll look after I solve the problem and see what I missed. So yes, feel free to point out silly mistakes. Okay, but I won't look while I'm solving the problem. Okay, so the powers of 2. Okay, so I've got I need a 2 to the 4th from the 16, a 3 cubed, 5 squared, 7, just a 7. and then 11, 13, all the other primes, 19, 23, 29. Okay, and then n is m, well, maybe I don't want to do that. Okay, so 32 through 40. So I've got an extra 2 to the 5th now. I've got 3 and 11 is covered. 2 and 17 is covered. 7 and 5 is covered. 36 is 9 times 4. It's already done. 37. So, okay, n over m, I can just compute it directly. 2 times 37. 38 is done. 39 is fine. And 40 is fine. So it should just be 74. Okay. The AMC answer key from Eigenvalence. Oh. Where do you get the PDF of the test? Yeah, I got it from Ivy. Okay, I couldn't find it anywhere else. Okay, problem 9. Here we go. Right rectangular prism. We've got logs. Okay. The surface area and volume are numerically equal. Okay, so the volume is log 2, log 3. Is it just me or did he just lag? I might be lagging. Can you hear me? Yeah. Okay, let's go. Okay. Log base 4 of x. And that's the surface area, so it's twice the what is. I'm tempted to just plug in the answers and see which one works. Rather than actually solving this. Hey, don't tell me problem 10 is hard. I'll get there. Okay. Okay, don't tell me problem 10 is easy either, because then it'll look silly if I miss it. Okay, so I'm just gonna write ABC for these things. So ABC is 2 times AB plus BC plus CA. And is there something easier I could do? Oh, I could take the sum of the reciprocals. So if I divide by ABC, I get 1 equals 2 times 1 over A plus 1 over B plus 1 over C. Okay, that's easier. Oh, okay, now I can actually solve this. So 1/2 is 1 over A plus 1 over B plus 1 over C, which is log base x of 2, log base x of 3, log base x of 4. So it's log 2 plus log 3 plus log 4 all over log x. Okay, so it's log base x of 24. So x to the 1/2 is 24. So x is 576. Okay, and that's E. Okay. Now it's time for problem 10. Let's see if I agree. Okay, well, I can't agree yet, but I did skip number 4, so I'm gonna have to come back to that one. Okay, problem 10. Oh, let me scoot this down. Okay, the base 9 representation of the number n is this giant mess. What is the remainder when n is divided by 5? Okay. I mean, there are some patterns to these numbers. Okay, so it's 27 times, oh boy, what is that? 9 to the 9th plus 6 times 9 to the 6th plus 5 times 9 plus 2. Okay, and I want that mod 5. So it's 27 times minus 1 to the 9th plus 6 times minus 1 to the 6th plus 5 times minus 1 plus 2. Okay, well, and 27 is 2, so it's 2 times minus 1. Oh, okay, maybe I'm doing it right. 6 is 1, that's 1. 5 is 0. Okay, so it's minus 2 plus 1. Okay, 1. which is B. Did I get that right? What? What? No? Wrong? Wait, 27 is 2 minus 1 plus 6. It's plus 1 plus 2. It's wrong, right? Is it right? Wrong? Wrong, right? I got a different answer in the test. Okay. Wrong? It's wrong? Okay, wait, don't tell me what the... Okay. Don't tell me. 27 times 9 to the 9. That's 2 times minus 1. Yes. Plus the 2. That goes away. The 5 goes away. And I'm left with 6 times 9 to the 6, which is 6. Oh, why did I did 27? That's 27 base 9. Okay. Yeah. Yeah. I can't do 27. Okay. I thought I was so clever. Okay. So it's 27 base 9. Okay, is 25. That's better? Okay. Oh, so that doesn't even matter. So I get 6 times 9 to the 6 plus 2, which is 1 plus 2, which is 3. Okay, is that better? Why did I skip 4? Oh, because I couldn't find the right thing to divide it by and it was taking me too long. Don't tell me the answer, I'll get back to that. Okay, I hope D is the answer. If not, I'll have to do that one more time. Okay. Okay. 24 minutes. Okay. I appreciate the time check. Let me check. Yeah, I think I started at 2:20, 2:21 Pacific time. Okay. Two concentric circles of radius 7, radius 19. The largest circle has a chord. Well, I am not good at geometry, and I'm not going to draw this to scale, but okay, the larger circle has a chord, half of which lies inside the smaller circle. Okay. What is the length of the chord? Okay, so if I call this, I'll call this X, half that distance. This one is easy. Okay, now I'm scared because I make mistakes on easy problems. Okay, so I've got two right triangles. Okay, so half of, I guess I don't know this side. The large chord, half of which, oh wait, yeah. It's, oh, I guess, oh yeah, okay, this is X and this is also X because it's half of it. Okay, now what can I do? So I've got, this is the radius here, which is 17. And this is 19. Okay, so now I've got the Pythagorean theorem here. I don't know what this is. I'll just call it H. Anyone here actually? Oh, okay. Well, I'm glad you came here for fun. Okay, so we've got H squared plus 4x squared is 361, and H squared plus x squared equals 289. So I subtract these, I get 3x squared equals 72. X squared is 24. So then what's the length of the chord in the larger circle? Okay, so I've got 4x. X is 2 root 6, so it should be 8 root 6. Okay. I doubt you're nowhere near that. Yeah, the first, well, I couldn't get number 4. I'll come back to, Okay, do 4. Okay, fine. Yes. Okay. I mean, there's 7, 11, 13. I guess 11 isn't that hard to check. Okay, so, okay, 4 again. Okay. Try to somebody artist center. Oh. Okay, 20210A. And I think I narrowed it down to 3 or 9. It couldn't be 1 mod 7 because then we get something 3 or 9. Yeah. If it was 1 mod 7, then the sum would be divisible by 3. And it can't be 5 because then it would be a multiple of 5. So it's 3 or 9. Would you take suggestions? Okay, if I'm really desperate, I'll take one, but I think I'm fine for now. I guess I could group. What am I missing here? 202, 103, 103, or 202, 109. Okay, mod, I'm gonna try mod 11 since that's not too hard. So 202 times 1,000 plus 103. 202 mod 11 is, well, 198 is 0. So that's 4 times minus 1 plus 4. Oh, I think I just got something. Okay, so A better be 9. Please let that be the right answer. You got it. 1 plus A is not 4. Hmm? Oh, the alternating 2 minus 0 plus 2. Yeah, okay. Wow. Thank you for that. I can do some pretty advanced number theory, but apparently I forget divisibility rules. So thank you for the reminder, Rohan. Okie doke. Oh, yay. Okay, more number theory. Number 12. Okay, number of terms with rational coefficients in x q root 2 plus y root 3. Okay, so I've got x, well, I don't even care about the x's. I've got q root 2 to the k times square root 3 to the 1,000 minus k. Okay, so thank you, Nicholas. Okay, so 3 divides k and 2 divides 1,000 minus k, so k is just a multiple of 6. Is it really that simple? Okay, so then I go from 0, blah, 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 up to 166 times 6 is 996. So that should be 167. Oops, 167. Okay, that was not much number theory at all. 6, yeah, 3 divides k, and 2 divides k as well. Okay. Well, okay, I can do these tests fairly well now, but back in the day, I didn't make it for 2 Olympiad either, so don't feel bad. The angle bisector of the acute angle formed at the origin by the graphs of 3x and x as the equation y equals kx. This sounds like some trig. Okay, so I've got y equals 3x and y equals x. Okay, so this angle is 45 degrees and this angle is arctan 3. Okay. Okay, so that's arctan 3. Well, okay, I just need the average of these angles. So I've got arctan 3 plus 45 degrees, so, and I average those, and that's whatever this angle is. And then I Yeah, I was thinking of doing the Amy. I could try the GMO. I think it would be 3 hours of watching me do problem 1 or trying whatever number 3 problem is on there. But if people want to see that, I'd be happy to give it a try. Okay, maybe IMO if I'm really feeling ambitious. Yes, IMO is 2 days, 4.5 hours each day, 3 problems. Yeah, Justin Stevens, the binomial theorem guy. I don't know him personally, but I know he's written some number theory stuff. Yeah. Oh, cool. Yeah. I've chatted with him, but I wouldn't say I know him at a personal level. But yeah, I know he teaches for AFs. Anyway, okay, so I need to take the tangent of this giant thing. Um, uh, uh, okay, so the tangent half angle formula is there's a better solution. I'm sure there is, but um, I'm just don't trick bash. Don't trick. Are you sure I shouldn't trick bash? I mean, I know the answer isn't 2. I say Amy, but oh, aim. I'm pretty sure Richard Russick says Amy, so aim, AIME. Now I don't know. Don't trick bash. Okay. Well, you're sure there's a better solution? What am I missing something here? Use geometry. Okay. Do I have to? Oh. Oh gosh. Okay. So I guess you do something like, okay. Yeah. Okay. So I've got 1 here, and then this is 1, and this is 2. Ah. And then I'm bisecting that. Triggers. Yeah, okay. I'm more comfortable with trigonometry, but I guess we'll, so that's root 10. Okay, so then this is root 2. Okay, so so if this is A, this is 2, or maybe I should have A be down here. This is 2 minus A, and now, okay, this over this equals this over this, so where should I write it? Okay, so A, well, that's a waste of paper. Let me move this down. A over root 2 equals 2 minus A over root 10. Okay, yeah, that's better. So A equals 2 minus A over root 5. So root 5A equals 2 minus A. So 1 plus root 5A equals 2. So A equals 2 over root 5 plus 1, which is root 5 minus 1, wait, times root 5 minus 1. Yeah, over 2. Okay, and then I really want 1 plus A, so 1 plus A is 5. Yep, of course it's the golden ratio. Okay, so that's A. Okay, but let me just say, thank you for the help, Lucas. The way I would have done this would be basically, so I take tan of arctan 3 plus 45 degrees. So I use the tangent sum formula. So that's 3 plus 1 over 1 minus 3 times 1, which is 4 over minus 2. So that's minus 2. And then I want an angle or if I double it, I get minus 2. So I want 2 tan theta over 1 minus tan squared theta equals minus 2. So I cancel the minus 2's. And I get tan squared theta minus 1 equals tan theta. Yeah, so tangent theta is the golden ratio. Okay, well, now it seems easy, but in hindsight, everything is easy. Okie doke. We're about halfway through in terms of time. Oh no. 14. Oh, trig is a lot of it's covered in pre-calculus because it uses some more sophisticated tools than basic geometry, I'd say. And it also, with trig, it really helps to know the connection between trig and complex numbers, and that's usually covered in pre-calculus. So, but you can definitely do a lot of trig with just geometry. Okay, we have a concave hexagon, 3 non-adjacent acute interior angles that are 30 degrees, enclosed area. Oh, okay, I think I see what to do for this one. Okay, so these are all 30. Okay, and then if we cut this off, this is obviously an equilateral triangle. What is the perimeter? Okay, so the enclosed, let me just call this side length X. Then if this side is X, this side length is X over 2. Wait, I just want to make sure that I'm getting this right. Oh no, it's 15 degrees. Don't tell me. Don't tell me. I'm supposed to be doing this on my own anyway. Enclosed area is, yeah, okay, I guess I use law of sines. Again, I'm gonna use trig because that's what I'm most comfortable with. What is the perimeter? Okay, so I just need to find X. So this side here is, this is not going to be pretty, but it's, so I cut this angle in half and I get two 15-degree angles. So this is X sine 15 degrees. So the whole thing is 2x sine 15 degrees. Okay. And then the area of that is root 3 over 4 times the square of that. So I get 4x squared sine squared 15. Okay, so that's root 3 x squared sine squared 15 degrees. Okay, and sine squared, I can simplify that. It's, okay, I got to use the half angle formula. Okay, so it's 1 minus 2 cos 30 all over 2. Is that right? Minus 2 cos 30, or 2 cos 30 minus 1. I always get those mixed up. Or 1 minus just cos 30. Yeah, there we go. So 2 sine squared, 1 minus 2 sine squared. Yeah. Okay, so it's 1 minus cos 30, which is root 3 over 2. Okay, so it's root 3 x squared times 1 minus root 3 over 2 all over 2. Okay, so it's root 3 x squared times 2 minus root 3 over 4. Okay. Okay, and then I've got the 3 triangles here. So it's 3 times 1/2 x squared sine 30. So that's 3/2 x squared times, well, sine 30 is just a half. So it's 3/4 x squared. Oh, that's convenient. It cancels with that root 3 over 4. Okay, so I've got 3/4 x squared plus root 3 over 2x squared minus 3/4 x squared. And that whole thing should be 6 root 3. Okay, so x squared is 12. So x is 2 root 3. Okay, and then I multiply that by 6. Wait. Uh-oh. Wait, 2 times. I don't have an 18 root 3 option. Or wait. Okay, no, it's 12 root 3. Okay. Yeah. Okay, 12 root 3. Okie doke. Yeah, I've got less than I've got about 35 minutes left. Yeah, I mean, you could use geometry, I guess, but rather than doing all that trig stuff, but I didn't see a quick way of doing that. I'm sure there is another way, but okay. Oh boy, 15 is a long statement. Okay, so I've got a polynomial. Oh, 16 is also long. Okay, so I've got polynomial and its conjugate. Okay, f of z is 4i times the conjugate of z. And I want to find the polynomial whose roots are 4i times the conjugates of these. Okay. So I'm starting with, one second, let me check my YouTube to see if people are over there. Okay. Okay, back to the problem. Okay, so we start with z to the 4th plus 4z cubed plus 3z squared plus 2z plus 1. And we want 4i times the conjugates. Okay, well, I think I'm just going to break out Vieta's formulas. So I guess I'll call them z1, z2, or maybe r, I don't know. r1 plus r2 plus r3 plus r4. Okay, so that's minus 4. So, well, no, I don't even need those. I just need b and d. Okay, b is, well, 4i. Okay, 4i times 4i times the conjugates of all of these. Oh, okay, so that's just minus 16 times the conjugate of 3. Okay, so that's minus 48. I don't think the conjugation makes any difference because they're already in conjugate pairs. Okay, and then D is 4i to the 4th times the product of the R1, R2, R3, R4 conjugate, and that's all 1. So this is 4 to the 4th, I to the 4th, so that's 256. Okay, B plus D is 208. Okay. That really wasn't as bad as it looked. Yes, IMO and JMO problems, anything beyond AMI essentially is proofs. So it's a very different kind of competition. 16, an organization has 30 employees, 20 of whom have brand A, 10 have brand B. I don't like counting problems. I'm going to skip that and maybe come back to it. Okay, 17. How many ordered pairs does... Oh, neither x squared plus bx plus c nor x squared plus cx plus b. Neither of them have two distinct row solutions. So the discriminants should be at most 0. So b squared minus 4c is less than or equal to 0, and c squared minus 4b is less than or equal to 0. Okay. Okay. So, and they're positive integers. So I could say b squared is less than or equal to 4c, and c squared is less than or equal to 4b. So if I square this, I get b to the fourth is less than or equal to 16c squared, which is less than or equal to 64b. So b cubed is at most 64, so b is at most 4, and similarly c is at most 4. Okay, I guess I just plug these in now. Okay, so if b is 1, then c squared minus 4 is at most, oh, okay, 2, 3, 4. Okay, so b equals 1. That gives me, don't silly this, okay? Now you're making me nervous. Okay, okay, b equals 1. I get 1 minus 4c is less than or equal to 0. So c can be anything. And c squared is at most 4. So I get 1, 1, and 1, 2. Yeah, I think that's right. Okay, b equals 2. I get c is at least 1, which is still fine from the first inequality. And the second one is c squared is less than or equal to 16, or 8, sorry. So I get 2, 1, 2, 2, and I think that's it. C squared minus 8, yeah. Okay, b equals 3. I get c is at least 9/4. So c is at least 2, or at least 3. So 3, 3 works. Does 3, 4 work? C squared is less than or equal to 12. No. And then 4 equals 4. I've got c is at least 4, and here I've got c squared is less than or equal to 16. So 4. Okay. It should just be 6. Did I silly that? Rohan, you're my only hope. Okay. More counting. I'm going to skip that one as well. Here's where I have to get strategic because I don't want to waste too much time on problems I can't really do. Okay, x is the least real number greater than 1. Okay, such that sine x equals sine x squared, and the arguments are in degrees. Okay, 51 minutes. Yes, thank you. Okay, so 2 sines are equal. So here's the graph of sine x. The first place where they can be equal is if they're symmetric around 90 degrees. So x plus x squared equals 180. I think that's right. Otherwise, well, let me just see what this gives for x. So x squared plus x is 180. So x is roughly, okay, so 13 squared plus 13 is too big. That's 182. So x should be about 13 degrees. Or, I mean, x is just less than 13 degrees, but it's definitely bigger than 12 degrees. And I don't think I could get any other solutions. Because, well, that's the first place where they can be equal, so I don't think that's going to happen. Well, and the only other smaller answer is 10, and that won't work. Okay, that was a very easy 20 or 19. Assuming I did that right. Okay, 20 is a number theory problem, my favorite. Okay, F1 is twice the number of positive integer divisors of n. Okay, so twice the number of divisors. And okay, Fj of n, I prefer k, so F1 of f, k minus 1 of n. Okay, for how many, F50 of n equals 12. Okay, I want to know the number of values satisfying that. Okay, let me start out with a prime. So F1 of P is 2 times the number of divisors of P, which is 4. F2 of P is 2 times the number of divisors of 4, which is 6. F3 of P is 2 times the number of divisors of 6, which is 8. Okay. I guess I'll keep going. 2 times the number of divisors of 8. 2 times the number of divisors of 8 is also 8. Welcome, Punxsutawney Phil. I think you're a bit early for spring, but okay. Let's see. So if I hit 8, I'm done for because 8 has 4 divisors. Okay, so I can't hit 8. I'm gonna box that because that seems important. Okay. Okay, so n can't be a prime. That already knocks off a lot of values. When I can't even hit anything, I can't hit 4, 6, or 8 because then I'm in trouble. Because eventually, well, I could hit 4 or 6 at the very end. Okay, so I can't, let me cross that off again. Can't hit 8 at all, and I can't hit 4 or 6 before, say, F47, because then I'll get to 8. Okay. Well, yeah. No, I can't hit it at all. Okay. No. Okay, so it is 4, 6, or 8. I can't hit those at all. Okay, so that means it can't have 1, 2, or 3 divisors. 1, 2, 3, or 4 divisors. So n has at least well, no. Okay, so say n is p1 to the alpha 1, pk to the alpha k. So the number of divisors is 2 times alpha 1 plus 1 up to alpha k plus 1. And that can't be 4, 6, or 8. I'm never going to get 1 unless n is 1, so that's not that interesting. So alpha 1 plus 1, alpha, well, whatever, alpha k plus 1 is at least, can't hit 2, 3, 4, so it's at least 5. So I could have the 4th power of a prime. I could have, that's if I have 5 divisors. If I have 6 divisors, I could have a square times a prime. That's the, or a 5th power. If I have, I have 7, then I have to have a 6th power. Okay, if I have 8, I could have a 7th power, a cube, and a prime. I think that's it. 1 times just 8, or 4 times 2. 2 cubed times 3. Okay, I don't think I have to go much further. I can't have any 6th or 7th powers. Okay, if I have 9 factors, then let's see. Then I could have an 8th power, which I can't, or I could have a square of 2 primes. If I have a 10th power, that's 2 times 5, so that's p to the 4th q. Okay. I think I'm running out of options here. So yeah, I can't get anything beyond that. Okay, so let's see what happens. Okay, so if I have just a prime power, I can have 2 to the 4th, 2 to the 5th, and that's it, actually. So those are done for. P squared q can be 2 squared times 3, 3 squared times 2, 2 squared times 5, 2 squared times 7, 2 squared times 11, and I can't go beyond that. I can't have any others, I don't think. 3 squared times, 3 squared times 5. Okay. I know this is tedious, but I can't think of a better way of doing it. A square of something that's a product of 2 primes is, I could have 6 squared, and that's it, I think. Yeah, because beyond that, I'd have to do at least 10 squared. Okay, and then a cube times a prime, so that's 2 cubed times 3, or, well, I could do 2 cubed times 5, but I think that's it, because otherwise I need 3 cubed or higher, and that won't work. And then p to the 4th times q is 2 to the 4th times 3, because I can't have anything else. Okay. So my list is 16, 32, 12, 18, 20, 28, 44, 45, 36, 24, 40, and 48. Ugh. Okay, so how many are there? That's 12. Okay, so this sum of the divisors of, or the number of divisors of 16 is 10, is 5, and then I multiply it by 2, I get 10. And then what happens to 10? 10 has 4 divisors, so I get 8. Okay, that doesn't work. 32 has 6 divisors, that I double it, I get 12. 12 has how many divisors does 12 have? 2 squared times 3, that's 6 divisors. And I double that, I'm back to 12. Okay, so 12 is a fixed point, actually. So 32 does work. 12 works. 18, that's 2 times 3 squared. So that's a 6. Yeah, okay, that also works. Anything with 6 divisors is going to work. Okay, so p squared times q, 2 squared times 5, 2 squared times 11. Okay, 45 is, oh, 1 hour, 15 minutes already? Oh, yep, you're right. Okay, well, what time is it? 2:21. Okay, I guess I'll just, yeah, I'm gonna stop there. Okay, so that wasn't too bad. I spent a lot of time on that last one. Okay. Oh, yeah, that's right. I was wondering why it seemed like it went so fast. Okay, yeah, I've got 15 minutes. Okay, thank you. Okay, yeah, okay, I can finish this. 45 is 3 squared times 5. Yeah, that also works. 36 is the sum of those divisors. 2 squared times 3 squared is that has 9 divisors. 9 has 3 divisors, so I multiply by 2, I get to 6. Then I'm in this loop, so that doesn't work. 24 has that's 2 cubed times 3, so that's 8 divisors. That's, oh, but I doubled that. Oh wait, no, 36. Let me go back to 36. 36 had 6, or no, 9 divisors. I double that, I get 18. Then 18 does work. Okay. 24 has, oh, this is hard to do on my head. That's 2 cubed times 3. That has 8 divisors. Then I double that, I get 16. Then 16 has 5 divisors. I double that, I get 10. And then I think 10 gets me back into that. Yeah, that gets me into the 8 loop. Okay, 40 is 2 cubed times 5. And then that again has, wait, 2 cubed times 5 is, yeah, that is 8 divisors. And then I multiply that by 2, I get 16. Okay, and finally, I have 5 times 2 divisors here. So that's 10, and then I get 20, and then 20 does work. Okay, whew. So I've got 9 numbers. Okay, I hope that's right. Okay. Now let's see what I can do with these last few. I think it's 10? Oh, no. Okay, let me go back to this. What am I missing here? Okay, I guess I'll look at that later, figure out what I missed. Okay. 23 is algebra, so maybe that's doable. So I guess I'm gonna take a shot in the dark and do 23. I'm not optimistic about being able to solve 23, but I've got a quadratic P of, okay, so P of X, I'm gonna say, oh, it's monic. Okay, so it's X minus R, X minus S. Well, maybe A and B would be better. Okay, so P of X is P of X minus A, P of X minus B, and this has 3 real solutions. So it's got to have, P has to have, well, this has to have 4 roots with multiplicities counted. So either P of X minus A or P of X minus B has a double root. Okay, and when does the, okay, so the discriminant is 0. Okay, let me, so this is x squared minus a plus b, x plus ab. Okay, so I want p of x minus a to, that's going to be x squared plus minus a plus b, x plus ab minus a, and then p of x minus b equals x squared minus a plus b, x plus, well, okay, that's symmetric, so it doesn't matter. So one of these discriminants is 0, so I'll just say the first one. So a plus b squared minus 4 ab minus a equals 0, and I want to maximize a plus b. Okay, so I've got a plus a squared plus 2ab plus b squared minus 4ab plus 4a equals 0. Okay, so this is a minus b all squared. Okay, so a plus b squared minus 4ab plus b squared minus 4a equals 0. Okay, so a, this is a minus b all squared. Okay, so a plus b squared plus 2ab plus b squared minus 4a equals 0. Okay, so a, this is a minus b all squared. Okay, so a minus 4ab plus 4a equals 0. Okay, so a, this is a minus b equals minus 4a. What can I do with that? Okay, so a is going to be negative. So maybe I'll say a equals minus minus u. Okay, so I get u plus b squared equals 4u. Okay, so this thing is at least u squared. Well, unless b is negative. Oh, shoot. Okay, I could have, okay, so let me suppose b is non-negative first. So then u squared is less than or equal to u, it's less than or equal to 4u, so u is less than or equal to 4. Oh, I know. I really care about a plus b, so I'm gonna introduce a variable for that. So let me say s equals a plus b. Okay, so s squared minus, I don't want to do this. Maybe plus 4a. Sorry, minus 4a. Okay, that's 4a times s minus a minus 4a. So that's 4a s minus 4a squared minus 4a. So s squared is 4a. Okay, so s squared minus 4as plus 4a squared plus 4a is 0. And I want this to have a solution for s. And I want to make s as big as possible. So, okay, s equals 4a, well, I want a plus sign here, plus root 4a squared minus 4 times 4a squared plus 4a. Maybe there's probably an easier way to do this, but so it's 2a plus root, that's 16a squared minus 16a squared minus, wait a second. Oh, yeah. Minus 16a all over, well, let me make, okay, there. Okay, so s is 2a plus root. So this a squareds go away, and I get root minus 4a. So I get 2 times a plus root minus a. Okay. So, which is some of the roots is maximized. Yeah. Okay. So I think I need a new page. Okay. So s, remember, was a plus b, but that's also 2 times a plus root minus a. Okay. So if a is minus, it's minus something squared, minus t squared, then s is 2 times minus t squared plus root t. So that's t. Okay. And minus t squared plus t is less than or equal to a quarter when t is a half. That's where the vertex is. Now we're 10 minutes. Thank you. Okay. So s is less than or equal to a half. Okay. So a equals minus a quarter, b equals 5 quarters. I hope that's right. So then I get p of x equals x squared minus x plus, sorry, minus 5/8. Okay, is that gonna work? AB minus A. I'm not sure I can do this in time. Oh, 5/16. And if I add on a quarter. That's not going to quite work. It's minus a quarter. Yeah, I'm not sure I can get this one in time. Okay, so do I have? Oh yeah. Okay, I've got just a few minutes. Yeah, I don't know if I can get this. I think I've got the right idea, but so a plus b squared equals 4 times a. Okay, s squared minus 4a plus 4a squared plus 4a is 0. S equals 4a plus minus 16a squared minus, okay. Yeah, okay. 2 times a plus root minus a. Quarter plus minus a quarter plus, yeah, okay. And then b, what was b? Oh. Wait, oh, 3/4. Ugh. There, I was making a silly mistake. Okay, minus 3/16, and then I add a fourth, I get x minus a fourth, x minus a half squared. Okay, so then finally p of 1 is minus, oh no, so that the sum of the roots is maximized. Oh wait, x minus a half squared. Some of those is a half in the product. Okay, so then I add on a fourth, I get x minus a fourth squared. Okay, good. So then p of x, or p of 1, is a half minus 3/16. Okay, so that's 8/16. Okay, 5/16. Okay, I hope that's right. Okay, is that? I think that was a bit less because I started a few minutes in, but I'm gonna call it there because I don't think I can get any more. Okay, I guess now I'm going to go through the answer is A. Whew. Okay, thank goodness. Okay, let's see my score. Yes, let me go to the score page. Let me open that up. History. Yeah. Okay, I'll share my screen. Okay, again, this is from Ivy League Center if you want to take a look. Okay, so I did get help on that one problem with trig, but the rest I pretty much did myself. Okay, so I've got to go back through all my papers and find what answers I wrote down. Okay, so I got C for number 1. That's good. Then E, then B. Then 4 was wait. Oh, 4 was E, yeah. Then 5 was B. 6 was D. I'd be more organized if this were the real test, by the way. D, E, yeah. Then D. Oh yeah, I messed up on 10. I messed up because I wrote 27 base 10 instead of base 9, so I needed help on that one. Okay. E was 10 was D, 11 was E. Okay. Let's see, which one was this? Oh, 12 was C, 13 was A. That's the other one I got help on. I skipped 14. Okay, that's 13 right so far. 15 was D. I think I skipped 16. Yeah, 17 was B. I skipped 18. 19 was B. 20 was, no, 20 was D. Okay, and then 23 was 5/16, which is A. Okay, so I got, let's see, I got 1 through 13. Okay, so that's 13, and then I skipped to 15, 14, 15, 16, 17. Okay, I think I got 17 of them. And a couple of those were with help. So that's a bit worse than I got in some of my previous videos. But it was a little different because I was talking to people, and I'm going to use that as an excuse for not doing as well. So yeah, my score was 102, which I think would make Amy. I'm not quite sure. I'm not good with knowing the cutoffs. But I will have a video next week for the 12B, probably through Zoom, unless I can get YouTube streaming to work. But thank you for coming, and oh, and I'll probably do the Amy as well, if enough people are interested. Please do, I know. Okay, if you really want to sit through that, I will try to find time in my schedule to do that. I might have to break it up into smaller blocks or something. We'll have to see. I don't know if I can do 4.5 hours 2 days in a row. But I'll definitely have the AMC problems. I'll have another one of these next week, and then the Amy, whenever that is. I don't know. I'll have to double check. Who would your team beat? Richard Bresick? Oh, for the IMO? If I could go with anyone, you mean? Richard Bresick. Trying to think of other people. Probably Evan Chen, because he can do a little bit of everything. Gosh, it's hard to pick. Let's see. Oh, Potion Low, yeah, that would probably be cheating because he's been the director. But yeah, Potion Low, Chidu Andrescu, probably all the people who have math companies and math camps now. I suppose that's cheating. I think you're supposed to be a high schooler. But anyway, I hope to see you again next week. And let me check when the Amy is. Oh, the Amy isn't until February. Okay. So that'll be a while. But I'll have the AMC 12B video next week, and I'm also probably going to record some old AMC 12 videos, and I'm on 2022. Oh gosh, has that even been scheduled? It just says to be determined on the MAA website. So the US AMO is March 22nd and 23rd. I think the IMO is usually in summer, but that is probably changing due to COVID. I don't know. Okay, but I will see you soon. If not here, then probably on the AOPS forum somewhere. And thank you all for coming. Bye.